to explain some general method to solve questions like our homework question number 23. Right? Yeah, first let me describe this example first. Okay? FP, floating point, FP SQR, floating point square root type. Okay? I told you before, this type of operations mainly used in computer graphics applications. So it's very important. So in this example, the information we have, given a program, there are several operations in the program. It is known that floating point operation, the frequency is 25%. It's CPI 4.0. FPSQR, frequency 2%. CPI 20.0. Other, okay? The other, so what's the meaning of other operations? Other than FP, okay? Or we can say non-FP operations, okay? The frequency can be found because other than FP, 75%, okay? It's CPI given 1.33, okay? So now the question is, because the CPI of FPSQR is too high, so that means the performance is too slow. So in order to improve the performance of the whole program, we like to reduce its CPI. So for this question, it is reduced to 2.0. Okay? So big improvement. You can see even smaller than other FP operations. Yeah, whatever. We just take the number here. Okay? The question is, what is the overall CPI after the improvement? Okay? Yeah. All right. So let's look at the idea how to solve this type of question. Okay? We know solving the questions like this, we mainly use the formula that processor performance equation. Okay? So the main tool we use, okay, PPE, processor performance equation. Okay? Yeah. So we know, based on that equation, the overall CPI, okay, overall CPI, okay, overall, okay, equals summation, okay, look at your operation numbers, okay, frequency times individual CPI, okay, so that is the formula. And the definition, the frequency, we know, given here. Okay? Yeah. All right. Let's draw a diagram. Okay. Typically, we draw a diagram. This line segment represent all operations. Okay. Then, let's do some partition. Okay. First, FP part. Okay. So that is 25%. Okay. And remaining part, so we call non-FP. Okay. 75%. Okay, all right. Next, FP-SQR. FP, we know this type of operations are part of FP. Okay? So it's inside FP. Okay? FP-SQR. Okay? 2%. All right. So here I want to explain this 2% a little bit. Okay? Its frequency is 2%. So what's the definition of frequency? So remember, we learned the definition of the frequency. Fi equals ICI over ICO. Okay? Instruction count. Okay? So its definition is instruction count of this operation, of this FP-SQR operation, instruction count, over the total instruction count for all operations. Okay? All right. So that means this 2% means 2% of all operations. Okay? Not 2% of 25 FP operations. Yeah. Just, similar to our question 23, some students may feel that 2% could be 2% of the floating point. That's not correct. Okay? The frequency we mean, among all the operations, not among only FP operations. Okay? All right. Then, inside the floating point, let's look at the remaining part. Okay? We have this remaining part. Okay? Okay. Yeah. Remaining part, we also we give a notation, so we can call non-FP SQR, but inside FP. So I draw this vertical bar. Okay? Yeah. Because if I just call non-FP SQR, so probably people may feel include non-FP, because non-FP also belong to non-FP SQR. So that's why I use this restriction on it, so avoid confusion. Okay. All right. Now, okay, you see, this is the diagram. Okay, we need to solve this problem based on the diagram. Okay. All right. Before we apply the PPE, okay, we need to do another step analysis here, important step of analysis here. Okay. You see, how do we look at all the operations? Okay. Here I give two views of the way to divide all the operations. So I call partitions. Okay. The first way, partition 1. Okay. Partition 1, so that means all the operations can be divided into floating point operations and non-floating point operations. So that is our first partition. Okay. Partition 2. Okay. For partition 2, we can view in this way. All the operations can be divided into 3 parts. Okay? FP-SQR, non-FP-SQR under FP or inside FP, and non-FP. So 2 different partitions. Okay? because when we use equation, we need to base on one of the partitions. Okay. Now I apply PPE. All right. Okay. First time I use the PPE. Okay. PPE on partition 1 for old case. So I write it this way. For old case, what's the old case? Old case, that means before improvement. Okay? We use this big CPI number for FPSQR. Okay? New case, we use that improved, much smaller number for FPSQR. Okay? So we have two cases, old and new. Okay? Now for that old case, okay, our CPI old, okay, I use this old, okay, equals, okay, partition 1, 2 terms, okay, frequency 25%, okay, CPI 4.0 plus 75% frequency, 1.33 CPI. Okay? Yeah. 1.0 plus another 1.0 equals 2.0. Okay? So the first equation. Okay. All right. Next. Let's look at the other cases, okay? Because there is a partition 2. So here we have to use partition 2 because the numbers given, we need to use FPSQR operations. So that's the partition number 2. So partition 1, you cannot see FPSQR. Okay? Yeah. All right, so the next application of PPE, this time we use partition 2, but still for the old case. Okay? Yeah. Before improvement, let's look at the PPE using partition 2. Okay? Yeah. Because this time CPI also old. Okay? All right. Now partition 2, 3 terms. We use 3 terms here. Okay? Yeah. Yeah. 2%, 20.0 plus 23%. Okay? Yeah. Because the remaining part inside FP, 25% minus 22%, 23%. Okay? CPI at this point unknown. Okay? Yeah, unknown. So non-FPSQR inside FP. All right. Okay. The name is a little longer. Plus the third term. Okay. Third term. Okay. Okay. All right. We do not need to simplify this at this point. Okay. We just leave there. Okay. Yeah. Yeah, because if you simplify it too early, it may not be good. May not be the best way. Okay? All right. Now next we need to apply PPE the third time. Okay? All right. This time on new case. Okay? PPE P2 new. Okay? New. Okay? All right. CPI new All right, okay. This time 2% times 2.0 plus, okay, remaining no change, okay, no change, 23 keep it. All right, just copy. All right. Our goal is to find this number. Okay, this number. Okay, all right. And we compare the last two equations. This number, CPI old, we found it. Okay, and you see the first term, they are different. Second term, same. Third term, also the same. Okay? If you compare two equations, if you take difference of these two equations, so you can see the difference only comes from the first term. Okay? All right. CPI old minus CPI new equals 2% times 20 minus 2, okay, 18 multiplies 2%, 0.36. Okay, so finally, let's use the space here. CPI new equals CPI old minus the difference 0.36. Okay, 2.0 minus 0.636 equals 1.64. Okay, the answer. Okay, so we solve this problem. Right? So let's summarize the method we used here. Okay. PPE. Okay, so in order to use PPE, you need to get all the CPIs, frequencies, so you identify all those numbers. Okay, then the second important thing is partition. Okay, when you divide all the operations, what partition do you use to divide them? Okay, based on different partitions, the way you use the PPE is different. Okay, 3 different ways here. Okay, then you plug in the known numbers, you solve equations, then you can find the answer. Okay, all right. So that is the general way to solve this type of problems. Okay. If after you have this background, then it will be much easier for you to solve question 23. In the next step, I will explain question 23 a little bit. Okay. To explain